Okay, in example 3, we need to determine the quadrant that theta lies in. Actually, that turns out to be a big deal for us. Two things that we need all throughout trigonometry. One, we need to know the value of the trig function. And secondly, we need to know which quadrant we're in. Do remember that all trig functions, only the sign. All students take calculus, so all the trig functions are positive, only the sine, only the tan, only the cosine. So here when it says sine is negative, each trig function is positive in two quadrants and negative in two quadrants. So sine is negative. Well, all of them are positive here, sine is positive here. We must be talking about either quadrant 3 or quadrant 4. And we want the cosine to be positive. They're all positive in quadrant 1, and cosine is only positive in quadrant 4. So which quadrants satisfy all of those conditions? It has to be quadrant 4. The angle must be in quadrant 4. Meaning, when I draw my triangle always runs up to the x-axis. It's going to look just like that. And if I look at this part B, tan is negative. Well, tangent is negative in quadrants 2 and quadrants 4 because they're all positive in quadrant 1 and tan is positive in quadrant 2. Secant and cosine go hand in hand. So this says cosine is negative. We know cosine is negative in those two quadrants. So the quadrant that satisfies both of these conditions will be quadrant 2, which means if I draw my triangle, which is in the next example 4, I'm going to draw my triangle right there. And here we know x is negative and y is positive. Here we know x is positive, y is negative. So that's going to make a big difference. If I look at the next problem, this is what it says. Find value of the trigonometric functions. Find the value of the 6 trigonometric functions. The key is figuring out where is the triangle. That's really the key to solving either of those. So here, I glance at this, say, okay, well, let's see. If I take sine of theta is negative, so I know that sine is negative in quadrant 2, 3, or quadrant 4. And tangent is positive. Tangent is positive in those two quadrants. I must be in quadrant 2. So, theta must be in quadrant 2. In quadrant 2, if I draw my triangle will look like this. Nothing fancy. There's theta. Sine is the opposite over the hypotenuse. Hypotenuse is 3, and the opposite is a... Okay, I'm sorry. We said quadrant 3. Oh, yeah. I said 3 and I labeled 2. How smart. Quadrant 3, right there. So, my actual triangle looks like this. Otherwise, it wasn't working. Did you notice? And I'll show you what that means. So it has to match. There's theta, always along with the x-axis. And the opposite is a 1, and the hypotenuse is a 3. So isn't y negative right there? And the hypotenuse is always positive. And why is that? Because it resembles the radius of a circle. If you remember how this whole mess started. And the radius was the distance. So the hypotenuse is always positive. X and Y, depending on the quadrant, would be positive or negative. How can I find the missing side? Well, I know that 3 squared equals a negative 1 squared plus x squared. 9 equals 1 plus x squared. 8 equals x squared. And if I square root both sides, what happens every time I square root? I pick a plus or minus. And in this quadrant, is x positive or negative? In quadrant 2 or 2 or 3, x is negative. And now when they say find the value of the trigonometric functions, sine of theta is the opposite over the hypotenuse. Cosine of theta is the adjacent over the hypotenuse. And tan of theta is the opposite over the adjacent. And I don't mind you not simplifying for a test. For the homework you should. For the test, and I assume you could find the cosecant, the secant, and the cotangent. And if I get to the next example, the same deal. The first order of business is trying to figure out which quadrant am I in. That turns out to be half of the problem. So here, I want tangent to be positive. Tangent is positive in quadrant 1 and 2. And secant is associated with cosine. Cosine is negative in quadrant 2 and 3. Oh, it happened to be the same thing. That wasn't intended. Okay, I'm going to change the problem slightly. There. Sorry, but I don't want you to be in quadrant 3 in both problems. I didn't see that coming. So, I take tan of theta being negative. Well, that must be quadrant 2 or 4. And this is associated with cosine being negative in quadrant 2 or 3. So my angle must be in quadrant 2. I draw my triangle in quadrant 2. Always to the x-axis. And tangent is negative 3 over 1. So tangent is the opposite over the hypotenuse. The adjacent. Opposite over the adjacent. One of these sides is negative. Well, we know in the second quadrant y is positive, x has to be negative. And how do you find the hypotenuse? That's the square root of 3 squared, which is 9, plus 1 squared, which is 1. That's 10. It's radical 10. And once I figure that out, I could figure out what the sine of theta is, what the cosine of theta is, and what the tangent of theta is. Sine would be the opposite over the hypotenuse. And if you rationalize, that's 3 radical 10 over 10. Cosine will be the adjacent over the hypotenuse. If you rationalize, that's negative radical 10 over 10. And tangent is the opposite over the adjacent. And secant, cosecant, cotangent, you could figure those out with minimal work, just reciprocal of each of those. Now, something else we need to get out of the way in this section, an important idea, is the area of a triangle. That turns out to be very important on the long run. In calculus, we have to find the area, and those could be resembled by vectors. They could be resembled by many things. Consider the following triangle. So the idea is we have two sides are given and the angle included between the two. If I want to find the area of this triangle, that's 1/2 base times height. Remember, the height is always perpendicular to the base. So I'm given the base, it's right there, but the height I need to find. If I look at this triangle, I'm given the angle, I'm given the hypotenuse, and I want the opposite. Wouldn't the sine of that angle that's given be the opposite over the side that's given? If I cross multiply, wouldn't that mean that the height of the rectangle, of the triangle, is a times the sine of theta? So wouldn't that mean that area equal 1/2 b, and instead of h, can't I say that is a the sine of theta? So what does that mean? That means if you give me two sides, sides A and B, and the angle in between, I could find the area of that triangle by taking 1/2 the product of the sides times the sine of the angle in between. So if I look at example 5, that's one just like that. You're given a triangle with sides 4. Let's say this is side 4. Side 5. Let's say this is side 5. And included angle. The angle between them is 47 degrees. So that creates a triangle right there. If you want to find the area of this triangle, since I'm given the two sides and the angle included between, I know automatically area would be 1/2 the product of the sides times the sine of the angle between them. Now, that's an exact answer. If you have a calculator, if you allow a calculator on the test, you would say, well, okay, let's take 0.5 times 5 times 4 times, am I in degrees? I am in degrees, the sine of 47 degrees. The area would be 7.3. Again, if you're not using this for anything else, 1 decimal will do. And if they gave me the units, if they would have said this was 4 inches or 4 meters or 4 feet, then I would have said the area would be the square of those. And that pretty much takes care of the rest of the section.